Okay, hi everyone. Welcome to the YAP Educations. So today I want to discuss the Cambridge IGCSE Additional Mathematics 0006-13 Paper 1, October, November 2024. Okay, now we try going to the question 1. Okay, let's see the question 1. Okay, question A. Find the coordinates of the stationary point on the curve y equals to x plus 3, x minus 4. Okay, so you see this is a quadratic equations, right? So now we can start to expand. So y equals to x squared, never mind right here, x plus 3, x minus 4 here. Now we start to expand, so you will get x squared minus 4x plus 3x minus 12 equals to x squared minus x minus 12. Okay, because question says find coordinate of the stationary point. Stationary point. When you see this keyword, you can using the dy dx equals to 0. Okay, so you can write here. So you get dy dx equals to 2x minus 1. Okay, so you can take 2x minus 1 equals to 0, x equals to 1 over 2. So we can try to find y coordinates. So you can take y equals to bracket 1 over 2 square minus 1 over 2 minus 12. Okay, so you can using your calculator. Okay, so you will get answer, okay, 49 over 4. Okay, this question you also can using the, okay, again right here for other method. You can using completing the square. Completing the square, or you also can use x-axis symmetry. X-axis symmetry, it means x equals to negative b over 2. Here, okay, number 3, or you also can using the product rules. Okay, this is my methods. And then if you want to use the other method, you also can use completing the square x-axis symmetry using the product rules here. Okay, so now we already get the answer here. Stationary point bracket 1 over 2 negative 49 over 4. Okay, let's look at the question B. On the axis, sketch the graph of the y equals to modulus x plus 3, x minus 4. Stating the intercept with the axis. Okay, so now we already know x equals to negative 3 and x equals to 4 is, not is, are x-intercept, right? And then we try to look back. After I already explained here, the y-intercept is 12. Okay, y equals to negative 12 is y-intercepts. Okay, for now, we try to sketching the quadratic function. Okay, after we already sketching the quadratic function, you can draw the modulus. Okay, so now we'll try to draw first. Okay, negative 3 it means here. Okay, label 4 here. Okay, negative 12 here. So your graph will show this way. And then your minimum point is your minimum point. So you should be draw like this way. Okay, after that, because we need to draw the opposite, so you need to opposite. Okay, they will draw this part. Okay, so I try to erase all the part. Okay, we can draw. And then please don't forget to label. Here is positive 12, not negative 12. Okay. And then here we can label negative 3, 4. Okay. So this is your modulus x plus 3x minus 4. Okay, let's try looking at the question C. Okay, given that k more than 0, write down the values of the k for which the equation modulus x plus 3x minus 4 equals to k has exactly two distinct real roots. Okay, when you need to find the two distinct real roots, right? You need to sketch here. Okay, so you can try sketch first. Okay, k more than 0, so it means I cannot sketch here. So I should be draw here first. Okay. And then here is your maximum point, right? So 1 over 2, 49 over 4. Okay. So your k is more than 0, right? But it's lesser than 49 over 4. So you can label here 0, 49 over 4. Okay, now you can try to see. Here got 4 distinct points, right? So we don't take this part. Okay. And then you can try to draw the straight lines on this graph. Okay, when k equals to 49 over 4, you see how many? 3 distinct root, right? Still cannot accept. Okay. If more than 49 over 4, yes, you can see is 2 distinct points, right? K more than 49 over 4. So your answer should be 10 k more than 49 over 4. Okay, based on uh these diagrams here. Okay, I hope you can get it. Okay, so now we try going to the next question, question 2. Okay, this is a sketching graph of trigonometry functions. On the axis, sketch the graph of y equals to 4 plus 5 sine theta over 2 for theta between negative 360 degree until 360 degrees. Set the intercept with the y-axis. Okay, for now you can see here is b theta over 2, right? Now we try to recall back one period for sine equals to 360 degree, right? So you can take here theta over 2 equals to 360 degree. So theta will equals to 720 degrees. Okay, so you see it's until 720 degrees, right? So you sketch for the graph, you just sketch until half only. Okay, exactly we need, if you want to complete, right, 360 degree, but the one period is 720 degree. So but the diagram you can see is giving you is maximum is 360 degrees only. So you just sketch half only for this part, half only. Okay, so now we try to see, okay, what is the, okay, we don't see the 4 first, we see the 5 first. Okay, we see y equals to 5 sine theta over 2 first. Okay, see here is until 5, right? So we try to see. Okay, 2, 2, 4, 6, 8, right? So we can try to draw. Okay, draw here first. Okay, this is your Okay, sine over 2. Okay, so negative 2, negative 4, here is negative 6. So you can draw here. Okay, now we need to upwards. Well, upwards how many units? 4 units. You need to upwards 4 units first. So it means if you need to upwards 4 units, so you need to draw this part. Okay, here is maximum is 5, right? Plus 4, you will get 9. So you need to labels here. All right. So here's also 0, right? So you can labels here. Okay. So this is your new graph. And then we try to see, okay, here is a negative 5, right? Negative 5 plus 4, you will get negative 1. Okay, should be labeled here. Okay, 0, so until it's 4. Okay, so labels here. So this is your y equals to 4 plus 5 sine theta over 2. And then you see the blue is y equals to 5 sine theta over 2. Okay? Okay, for my suggestions, you can draw the original first. After that, okay, you try to imagine, okay, imagine by yourself is upwards 4 units. Okay, make sure you eraser for the blue parts. Okay, leaving your answer, leaving the purple lah. Okay, purple answers in your question papers. Okay. Okay, let's look at the question 3. Okay, find the values of the k for which the equation 4x squared minus k equals to 4kx minus 2 has no real roots. Okay, and then you see these keywords, no real roots, it means you need to using the b squared minus 4ac less than 0. And then for this equation, you need to try to form, okay, form in ax squared plus bx plus c, or in general quadratic equations. So you copy the question, 4x squared minus k equals to 4kx minus 2. 4x squared minus 4kx plus 2 minus k equals to 0. Okay, now we take negative 4k squared minus 4a is 4 bracket 2 minus k less than 0. Okay, so now we try to see. So here you will get 16k squared minus 16 bracket 2 minus k less than 0. 16k squared minus 32. 32 plus 16k less than 0. 16k squared plus 16k minus 32 less than 0. K squared plus k minus 2 less than 0. So now you can try doing the factorizations. K, k, 2, 1 to try to find out the critical value for the x. So you can take, because here we need to get a plus k, right? So make sure plus minus. So you will get x minus 1, x plus k plus 2 less than 0. So you can using your graphical method to solve the quadratic inequalities. So here you will get negative 2, here is 1. Make sure label the variable of the k, because you see now is the less than 0, right? So we should labels here. Okay, so you will get the answer is k between negative 2 and 1. Okay, so this is your answers. Okay, now we try going to the question 4. Okay, write the 3 plus 4 log base 2a minus log base 2b as a single base 2 logarithms. Okay, so now you need to write here. Okay, 3 plus 4 log, here is base 2, a minus log base 2 b equals to 3 log, yes, base 2 2, because we know log when c base and the uh, a here is same, right? Actually, it's equals to 1. Okay, so plus 4 log 2a minus log 2b equals to log 2 power 3 plus log 2a power 4 minus log 2b will equals to log 2, okay, 2 power 3 equals to 8. So 8a4 over b. Okay, so now we try going to the next question. Okay, question B. Solving the equation log base 10 base 10x equals to 4 log base x 10. Okay, so now you need to change the base. Okay, so I'll try right here. X equals to 4 log x 10. So better way, I change. Okay, log here is 10 over log is x. So I better take 10 tens here. So, okay, I will get log x squared equals to 4. Okay, 4. Okay, so I try. Okay, I will get log x equals to positive negative 2. Okay, so I can try to separate out. Okay, log here is base 10 equals to 2. X equals to 2. And log base 10x equals to negative 2. Okay, now we try to apply the formulas. Okay, now we need to change into the exponents form. So you will get x equals to a, b here. Okay, so you can write here 10 power 2. X equals to 10 negative 2. So x will equals to 100. X equals to 1 over 100. Okay, so now we already finished the questions. Now we try going to the next question. Question 5. The polynomial p is such that px equals to ax cubed plus bx squared minus 19x plus c, where a, b, and c are integers. It is given that x plus 2 is a factor of the px. When the px is divided by x plus 1, the remainder is 20. Okay, for this sentence, you need to apply factor theorem. Yes, you should be apply the factor theorems. Okay, for the last question, you need to apply the remainder theorem. Okay, now we going to the question A first. Okay, show that 7a minus sorry. Okay, show that 7a minus 3b equals to 39. Okay, so how to get it? Okay, so now we try. Okay, x plus 2. Okay, so it means x equals to negative 2. So your px will equals to 0. Okay, so you can write here negative 2 cube a plus negative 2 square b minus 19 negative 2 plus c equals to 0. Okay. Okay, so here you can write negative a plus 4b plus 38 plus c equals to 0. Okay, so we get this equation first. And then now we see, okay, when x equals to negative 1, your px will get equals to 20. Okay, so you can apply here negative 1 cube A plus -1 square. B minus 19 -1 plus C equals to 20. Okay. Negative A plus B plus 19 plus C equals to 20. Okay. So let's see. Okay. So I can write here C equals to 8A minus 4B minus 38. And then here C equals to 20 plus A minus B minus 19. Okay, so C will equals to A minus B plus 1. Okay, so this is your first equations, second equations. So you can take first equations equals to second equations. 8A minus 4B minus 38 equals to A minus B plus 1. So 8A minus A minus 4B plus B equals to 38 plus 1. So 7A minus 3B equals to 39. Okay, so you already get these equations. Okay, now we try going to the next. It is also given that first derivative is divided by x minus 1. The remainder is 1. Find the values of the a, b, and c. Okay, so you can write here p x equals to ax cubed plus bx squared minus 19x plus c. So first derivative, you will get 3ax squared plus 2bx minus 19. Okay, so when x equals to 1, your first derivative here will equals to 1. Okay, so let's try. So 3a here is 1 square plus 2b here is 1 minus 19 equals to 1. So 3a plus 2b equals to 20. Okay, so we can solve using the linear simultaneous equals to 20. Okay, let's try. Okay, never mind, I try. Okay, multiply 2 is also multiply 3. Okay, you will get 14a. Okay, now we're using the elimination method to solve the linear simultaneous equations. Okay, 14a 6b equals to 39 multiplied 2 equals to 70. It's 9a plus 6b equals to 16. Okay, so I write here number 1, number 2 equations. So I can take number 1 plus number 2. So you will get 23a. Okay, so a you will get equals to 6. Okay, now we can try to find the value of the v. Okay, 2b equals to b equals to 20 minus 3. A is 6 here over 3. Okay, actually it's not, or 2. Okay, equals to 1. Okay, and then now we try to find the value of the c. Okay, okay, find the value of the c. Okay, Okay, so we can take C equals to A is 6 minus 1 plus 1. Okay, so you also get 6. Why? Because I take the equations from here. Okay, so I try to summarize my answer. A equals to 6, B equals to 1, and C equals to 6. Okay, now we try going to the next questions. The table shows the variable x and y, which are related by the equation y equals to ab power x squared, where a and b are constant. Okay, you can see this table. A, using the data to draw a straight line graph of the ln y against x squared. Okay. Okay, let's try. So okay, right here, y equals to ab x squared, right? So if you put the ln, okay, ln a plus ln b x squared. So ln y will equals to bracket ln b x squared plus ln a. Okay, so now you need to change this table. Okay, x will become x squared, ln y. So 1, okay, you can take 1.5 square. Okay, 2.25. 4, 2.5 square, 6.25. Okay, here's 9. Okay, lns y is 14. Okay, let's see how many decimal place should be here. Okay, for this part, we just take okay, I will take 2 decimal place first. So I write here 2.64. Okay, I draw the straight line to complete the table. Okay, okay. So now we try to find the values for the ln's y. Okay, so now I can take ln 33.3. So I will get 3.51. 102. Okay, so 4.72. Okay, lns 532.8. So you will get 6.28. And for the last, 8.18. Okay, so now you try. Okay, 1, it means here. Okay, but the value is 2.64, right? So 2.64. But you try to see, okay, 2 minus 1, it means here we have 1 unit, right? It means we try to divide it by 10 space here, you will get 0.1 units. So we can just accurate as 1 decimal place here. So we can take 2.6 only. Okay. Even though we already take 2 decimal place, not 2 decimal place, actually it's 3 significant figures here, or 2 decimal place. But in this graph, we can just apply with 1 decimal place only. Okay, so I hope you can get it. Okay, so now we can try to apply, to plot the points first. Okay, so I try to label 2.6. Okay, 1, 5, okay, 2.6. Okay. And then we see 2.25. Okay, here is 1 unit, right? Okay, 1 unit divided by how many? Okay, 0.2 units only. Okay, 0.2. So it means here is 2.5, right? So you need to take the half. Okay, 2.25, 3.5. What? Okay, label here. Okay, 3.51. And then we see the 4. Okay, 4, 4.72. Okay, 5, 6, 7. Okay, here. And then we try going to see 6.25. Okay, 6.25, 6.28. So I consider as 6.3. Okay, I try to label here. And then we try going to the last. Okay, 9. 8 point. Okay, now I take 8.2. Okay, so you make sure using your rulers to to sketch it. Okay. Okay. Make sure you're using your ruler to sketch this graph. Okay. And then we try to connect it to the y-intercept. Okay. So this is your y-intercept here. This is your y-intercept. All right. So now we already complete the straight line graph for the ln y against x squared. So now we try going to the question B. Okay, using your graph to estimate the values of the A and B. Give your answer correct to the one significance figure. So, okay, actually I already linearized the equations. So I will copy these linear line equations to write down here. So this is your linearized equations. Okay, now let's see. Now we need to find the values A, right? Actually, this is your y-intercepts. So I can take ln A equals to, okay, let's see from the graph. Okay, we can take the value is 1.9. Okay, we take 1.9. So A equals to E 1.9. Okay, E power 1.9. So you will get, actually it's 7 because the value is 6.7, right? But the question says give your answers correct to one figures. So make sure your A equals to 7. Okay. So now we try find the values of the B. Because you see B, long B here is right. It's a gradient. So you need to find the gradient first. Okay. So right here, ln B equals to, okay. For the point, because I already connect all the points, right? So I take the maximum and minimum point. Okay. So I write here 9 minus 1. 9 minus 1 over, okay, 8.18. 8.18 minus 2.64. 2.64. Okay. Okay, so here you can take okay, I write in fractions 400 over 277. Okay, so you can find the values of the b. Okay, so here is 4.2, right? Mm, eh, oh, sorry. I take wrong. Actually, I take wrong. Actually, it's 8.18 minus 2.64 over 9 minus 1. Sorry. Take wrong the values. Okay. Okay, 277 over 400. So now we try to find the values of the b. Okay, so it's 1.9987, right? So b equals to 2. Okay, now let's go into the question C. Use your graph to estimate the value of the x when y equals to 200. Give your answer correct to the two significant figures. Okay, so you can write here y equals to 7, 2, 2, x squared. And then your y 200. Okay, never mind. So I can use right here ln 200 equals to bracket ln 2 x squared plus ln 7. Okay, x squared equals to ln 200 minus ln 7 over ln 2. So x will equals to square root 200 minus. Okay, 2.2 here. Okay, so this is my final answer. Okay, why no negative? Okay, try to look back from this data because the questions didn't give you any negative values, right? So we didn't write the answer in negative value. Okay, actually we have the negative 2.2, but ignore. We just ignore it. Okay. Okay, now we try going to the next question. Question 7. Okay, question 7a. Given that y equals to x cubed, okay, ln x, find the dy dx. Okay, so how to find? So for this question, you need to using products rule. So I can write here y equals to x cubed ln x dy dx equals to 3x squared ln x plus 1 over x cubed. So we're equals to 3x squared ln x plus x squared. Okay, so this is your dy dx here. Okay, and then we try going to question B. Hence, find the integrate to 1 3x squared ln x dx. Give your answer in the form ln a plus b. where the a is an integer and the b is a rational numbers. Okay, now I can try write this way: d dx bracket x cubed ln x equals to 3x squared ln x plus x squared. Okay, because you see the question is, here is the main parts, right? So I try for 3x squared ln x in main subjects. Okay, so you can write this way: 3x squared ln x equals to d dx bracket x cubed ln x minus x squared. So you can write here, integrate two ones d dx bracket x cubed ln x minus x squared dx equals to x cubed ln x minus 1 over 3 x cubed to 1 here. Okay, so now I can try to substitute the values. Okay, 2 cubed ln 2 minus 1 over 3 is 2 power 3 minus, okay, 1 cubed ln 1 minus 1 over 3, here is also 1 cubed. But we know ln 1 equals to 0. So you can write 8 ln 2 minus 8 over 3 plus 1 over 3. Okay, so you can write here 8 ln 2 minus 7 over 3. But you see back the questions, the questions 1, the answers in the ln's plus b. So you need to take the 8, put here power 2. So you can write here ln's 2 power 8 minus 7 over 3 equals to ln's 2 power 8 equals to 256 minus 7 over 3. Alright, so we already get the answers here. Okay, let's go into the next question. Question 8. Okay. Question 8. Okay. The straight line y equals to 2x plus 1 intersect the curve y plus xy plus 3x squared equals to 15 at the points A and B. The point C with the coordinate 21 over 10 K lies on the perpendicular bisector of the ABs. Okay, it means this is your curve, right? This is your curve. And then you have the straight line that will intersect here, A and B. Okay, the point C is lies on the perpendicular bisector AB, right? So I draw, this is your perpendicular bisector AB. And then this is your coordinate C. Okay, I try to imagine like this way. Okay, A, find the exact value of the K. Okay, so what is your, for now is, you need to find, what's the thing? Okay, you need to find the point A and B first. Okay, why you need to find the point A and B? You find the point A and B to form the, and not to form, actually it's find the gradients. Okay, gradients between point A and B. Okay, after that you find the gradients, right? So you can try to find out the gradient at here. At the same time, you also need to find the midpoint AB. Okay, so let's try. I try for this part become as smaller. Okay, smaller part. So y plus xy plus 3x squared equals to 15. Y plus, no, 2x plus 1 plus x bracket 2x plus 1 plus 3x squared equals to 15. Okay, 2x plus 1 plus 2x squared plus x plus 3x squared equals to 15. So 5x squared plus 3x, here's 1, right? 1 minus 15, you will get negative 14 equals to 0. Okay, so now we try. Okay, doing the factorizations. Find x here. So I can try to separate out. Okay, 2, 7. Because I want to get positive 10 minus 7x. Okay, so I will get positive 3x. So positive, negative. 5x minus 7, x plus 2 equals to 0. X equals to 7 over 5. X equals to negative 2. Okay, so now let's try to find the y coordinates. Okay, you can using the straight line to find it. So you can take 2 bracket 7 over 5 plus 1. So you will get 19 over 5. 2 bracket negative 2 plus 1. Here is negative 3. Okay, so actually you already find the points A and B is right. So, okay, now you need to find the midpoint. Okay, midpoint of AB. Okay, so I can write here midpoint AB. So you can take 7 over 5 minus 2 divided by 2. 19 over 5 minus 3 divided by 2 equals to, okay, negative 3 tenths. Okay, 2 over 5. Okay, now you already find out the midpoint ABs, right? So now we can try to find the gradient AB. Okay, gradient AB. So I can take negative 3 minus 19 over 3 over negative 2 minus 7 over 5 equals to, okay, equals to 2. Okay, so now I can try to find the perpendicular. So you will get negative 1 over 2. So now you can try to form the equations. Okay, so I can take y minus 2 over 5 equals to negative 1 over 2 bracket x plus 3 over 10. And then, okay, now we try this is your coordinates C, right? So you can take 21, no, 21. K minus 2 over 5 equals to negative 1 over 2 bracket 21 over 10 plus 3 over 10. Okay. K minus 2 over 5 equals to negative 1 over 2 bracket 21 plus 3 here is 24 over 10. So 1 12. So here you will get negative 6 over 5. Okay, k minus 2 over 5 equals to negative 6 over 5, right? So k equals to 2 over 5 minus 6 over 5. So k, you will get the answer is negative 4 over 5 here. Okay, so now we discuss the question B. The point D lies on the perpendicular bisector of the AB such that its perpendicular distance from the AB is twice of the point C from the AB. Find the possible coordinates of the D. Okay, so now we can try to sketch for this part. Okay, I need to say something. The C is not here. Actually, C is here. Okay, now I try to sketch the graph. This is your AB. This is your perpendicular bisector of the BC. Okay. So, okay, this is your point C, right? This is your midpoint. AB, 3 over 10, 2 over 5. Okay, this is your point C. 21 over 10, negative 45, negative 4 over 5. Okay, now the question 6, find the possible coordinates of the D, right? So, okay, because the question didn't say the coordinate is more than C or less than C, right? Because the question says possible coordinate of the D. So you need to consider two possible. I mean D2 and here is D1. You need to consider these two parts here. Okay. Let's see. Okay, for D2. Okay, you see these are D2s, right? Because the question also mentions dm, this is your distance, equals to 2 times distance cms. Okay, so it means we see for the D2, okay, this is your straight line, right? This is your D2, this is your M, and then this is your C. Okay, uh, for this case, you see, D2M equals to 2 times cms, right? So this is C is a middle, right? Become as middle point or middle or midpoint D2M, right? So you need to take 21 over 10 negative 44 over 5 as midpoint D2M. Okay, and then bracket, okay, this is your x and y coordinates. So you can take negative 3 over 10 plus x over 2, y plus 2 over 5 over 2 here. Okay, so now you can try to find the x and y coordinates for the D2. So you can take x minus 3 over 10 divided by 2 equals to 21 over 10. X minus 3 over 10 equals to 42 over 10. X equals to 45 over 10. So x will equals to 9 over 2. Okay, let's see the y. Y plus 2 over 5 over 2 equals to negative 4 over 5. Y plus 2 over 5 equals to negative 8 over 5. So y will equals to negative 10 over 5. Y will equals to negative 2. So for this coordinate, 9 over 2, negative 2. Okay, I try for this part become as smaller. Okay, now we discuss for D1. Okay, now I try to sketch to draw. Okay, this is your D1, right? This is your midpoint, and then this is your C. A is quite far. Okay, this is your M, and this is your coordinate of the C. Okay, this time you see back again. The C is quite far, right? Because the questions already says, okay, dm equals to 2 times. So, okay, we can take, wait a minute, dm, this is your distance, right? Equals to 2 times distance cms. So, distance ratios to the cm equals to 2 ratios to the 1. So, you can write here 2 ratios to the 1. So, I will using the coordinates. Okay, coordinates formula. Okay, I write here. You can using this coordinate formula nx plus my divided m plus m. Here's x. Ny plus my divided m plus y. Okay, you can use this formula. This is a useful formula here. So you can write, okay, wait a minute. So this is your coordinate here. You can use negative 3 over 10, 2 over 5 equals to bracket 2, okay, C, okay, 21 over 10 plus x divided 3, y, 2 plus 1, 3. Okay, 2 again, negative 4 over 5 plus y divided 3. Okay, so you can take x plus 42 over 10 divided by 3 equals to negative 3 over 10. X plus 42 over 10 equals to negative 9 over 10. So x equals to negative 51 over 10. Now we try to find the y coordinates. Okay, y negative 8 over 5 over 3 equals to 2 over 5. So y 8 over 5 equals to 6 over 5. Okay, 6 over 5. Y equals to 14 over 5. Okay, so this is your coordinate 1 formula, negative 51 over 10, 14 over 5. Okay, so this is your possible coordinates of the D. Okay, I hope this way can help to you. The question 9. Okay. Okay, the diagram shows the trapezium OABC where the OA equals to 4A, OC equals to C, and CB equals to 2A. The point D lies on the AB such that AD ratios to the DB equals to 2 ratios to the 1. The point X is the point of the intersection of the line OD and AC. It's given that AX equals to lambda AC and the OX equals to mu OD. Okay, find the in the terms of the A and C. Okay, find the AB. Okay, AB. Okay, so we can take negative 4A plus C plus 2A. So you will get C minus 2A. OD. Okay, here. Okay, 2, 1, right? So actually I can take 1 over 3 AB. Eh, AB is direction here. Okay. So I can take 2 over 3 here. AB. Okay, so I can write OD equals to 4A plus 2 over 3 C minus 2A. 4A plus 2 over 3C minus 4 over 8, 4 over 3A. So you will get 8 over 3A minus plus 2 over 3C. Find the OX in terms of the AC and U. Okay, OX goes to mu bracket 8 over 3A plus 2 over C because OX equals to mu OD. Okay, AX. Okay, lambda AC. Negative 4A plus C. Okay. Let's see the question E. Okay, find the values of the lambda and mu. Okay. Okay, AX equals to lambda C minus 4A, right? So actually I can write here AO plus OX equals to lambda C minus 4A. OX minus OB equals to lambda C minus 4A. So O is here, right? OA and OA. Okay, 4A. OX Okay, so I can take 8 over 3 mu A plus 2 over 3 mu C minus 4A equals to lambda C minus 4 lambda A. Okay. Brackets 8 over 3 mu minus 4A plus 2 over 3 mu C equals to lambda C minus 4 lambda A. 8 over 3 mu minus 4 equals to negative 4 lambda. 2 over 3 mu equals to lambda. So this is your first equation, second equations. First, substitute to the second equations. 8 over 3 mu minus 4 equals to negative 4, bracket 2 over 3 mu. 8 over 3 mu minus 4 equals to negative 8, 3 mu. Okay, so plus 16 over 3 mu equals to 4. So mu will equals to 4 multiply 3 over 16. Okay, 4. So mu will equals to 3 over 4. Okay. Lambda equals to 2 over 3 bracket 3 over 4 here. Cancel, cancel. 1, 2. So lambda will equals to 1 over 2. Okay. Let's going to the next question. Okay, question 10. Okay, solving the equation 7 tangent square plus 5 tangents minus 2 equals to 0. Find the tangent between, for the tangents, not tangents, for the theta between negative 100 degree and 180 degrees. Okay, so let's try. Okay, you see this is a hidden quadratic equations, right? So actually we can solvings equals to 0. So now we can using the factorizations. 7 tangents here. 2 and 2 should be here. 1. So here is plus minus 7 tangents minus 2 tangent plus 1 equals to 0. Tangent equals to 2 over 7. Tangent negative 1. Okay. So now we can try to find the reference angle first. Okay. Okay, 15.9 degree. And then one more. Okay, reference angle. Theta equals to 45 degree. Okay, let's try to see. Because you see this value is positive light, so they will in first quadrant and second quadrant. So okay, now let's try. Because you need to find the value is between positive 180 degree and negative 180 degree. Okay, for the first quadrant, okay, you can take 15.9 degree. It's not wrong. But how to find in the third quadrant? So you should be to take negative 180 degree plus 15.9. So you will get here negative 180 degrees plus 15.9. So you will get negative 164.1 degree, 15.9 degrees. And then we try to look at the for next 45, because you see here is negative value, they will in second and fourth quadrants. Okay. So the second, so you can take negative 45, 180 degree minus 45. So you will get 135 degrees. Okay, next going to the next questions. Solve the equations 3 sine bracket 3 theta minus 1.5 minus 2 equals to 0. Okay, for between 0 and 3, this angles is in radius. Okay, so you can try to solve. Minus 2 equals to 0. So you can write here sine 3 minus 1.5 equals to 2 over 3. So now you can try to find the reference angle. Zero 0.7. Okay, so I take 4 significance here. Okay, 0.7297. Okay, so you can try to fix. Okay, value is positive. So 0 until 3, right? So 3 deduct 9. 0, so minus 1.5. Okay, I write the degrees here. Negative 1.5 multiplied 800 over pi. Okay, negative 85.9. 487 point. Okay, degree. Okay, because it's positive. Okay, so we can take. Okay. So I can take 0.7297 sevens. Okay. And then I can take pi minus 0.7297. And then one more is 2 pi plus 0.7297. Okay. Okay. So we can try right here 0.7297. Pi minus 0.7297. 2.4119. And the last 3 plus 1.5. Okay. 2.2297. 3.9119. 8.5129. Okay, now you can try to find the final answers. 2.2297 divided by 3, 0.743. Okay, 1.30. 2.84. Okay, so make sure your answers in 3 significance figures. Okay, now we're going to the last questions, question 11. Okay, the first 3 terms of an arithmetic projections are log base x3 log x, okay, 81. Okay, and this here, find the sum to the n terms, give your answer in the form k log base x3, where k is in terms of the n's. Okay, the a first term is log x3. Okay, now we need to try to separate out log, here's x3, right? So log x 81. 81 actually equals to 3 power 4. Okay, log, okay, x3 power 7. So you can write here log x3 4 log x3 7. Okay, so your common difference is 3 log base x3. So the sum, okay, s n equals to n over 2, 2a plus n minus 1 d n over 2, 2 log x3 plus n minus 1, 3 log, here is x, right? Okay, equals to n over 2. Okay, all right. So, okay, 3n log x3 minus log x3. So I can try to factorize out for this. I will get n over 2 bracket 3n minus 1 log x3. Okay. Okay, now let's see the question B. The first three terms of the geometric position are 1, 3 tangent square, 9 tangent power 4. Okay, for the angles here, and then find the theta of which this geometric position has sum to infinity. So now we need to find the common ratios. Okay, so we can take 3 tangent square over 1. So equals to 3 tangent squared. And then now we know sum to infinity, the ratio is less than 1, or the ratios, common ratios will be between -1 and 1. Right? Okay. So you can take here 3 tangent square less than 1. Here is -1. But for this part, we didn't see because the question says that we just focus on first quadrant only. Okay, so I just focus for this part. So we can take 3 tangent square equals to 1. Tangent square equals to 1 over 3. Tangent theta equals to positive negative 1 over square root 3. Okay, theta equals to, okay, now we try to find the reference angle. Okay, inverse tangent 1 over square root 3, you will get, okay, 1 over 6 pi, right? But you see, the question says we need to find in first quadrant only, right? First quadrant only. So your answer is very tightly lah. So you just take theta here 0, okay? And then here positive 1 over 6 pi's only. Okay, so I hope you can get it. Okay, so now we already finished for this paper today. Okay, and thank you watching for this video. Please like, share, and subscribe for my videos. Okay, we will see you in the next video. Okay, goodbye, everyone.